Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. This short video is going to, I suppose, deal with how to calculate the trace of a matrix. What's important in calculating the trace of a matrix is that we can only calculate the trace of a matrix when the matrix is a square matrix. Yeah. Okay. And just recall, that a square matrix okay, is a matrix, okay, that has the same number of rows as columns. Okay, as columns. Okay. So we can only ever calculate the trace. Okay. So the trace, okay, can only be calculated, okay, of square matrices. Okay. So what is the trace? So let's maybe provide a definition. So a definition. So given a square matrix, let's call it A, okay, the trace of A, denoted by, let's say, TR of A, okay, is the sum, okay, of the entries okay, on the main diagonal. Okay. And that's all there is. It's the sum of the entries on the main diagonal. Okay. So for example, let's consider a square matrix. Okay, let's say we have A is 2, 3, 7, 4. Okay, this is a square matrix. Well then, the trace of A, okay, is simply equal to the sum of the entries on the main diagonal. And the main diagonal is the diagonal from the first entry on the first row down to the last entry on the last row, last column. So the main diagonal always runs in this particular direction, if that makes sense. Okay? So the trace in this case is simply the sum of these two entries. So it's 2 plus 4, which then tells us that the trace of A is equal to 6. Now, let's just keep in mind that this isn't a matrix that has one entry. Okay? This is a scalar quantity. Okay, so it is just a constant term. So this matrix A has trace 6. Let's have a look at another example. Okay, let's say that B is the matrix 1, 7, 2, 5, 6, 3, 4, 2, let's say minus 6. Okay, well then the trace of B is simply the sum of the entries on the main diagonal. Okay, so down in this direction. Okay, so it's equal to 1 plus 6 minus 6, which tells us that the trace of B is simply equal to 1. Let's do one other example. Okay, let's say that C is equal to, let's say it's 1, 4, 3, 6, 9, 12. Let's say 14 to 18. Well then, this is a square matrix. Its dimension is 3 by 3. Well then, the trace of C is the sum of the entries along the main diagonal. So it's 1 plus 9 plus 18. Okay, which tells us that the trace of C must be equal to, well, 1 plus 9 is 10, plus 18 gives us 28. Okay. Let me do one final example. Okay. Let's say we do a trivial case here. So let's say that D is the matrix 4. Okay. This is an unusual looking matrix. Well, how many rows is there? There's one row. How many columns? There's one column. So the dimension of this matrix is, it's a 1 by 1 matrix. Okay. Now we defined a square matrix earlier on, to be a matrix that has the same number of rows as columns. So actually, by definition, this matrix, although it looks unusual, okay, is a square matrix. Well then, the trace of D, okay, which is the sum of the entries on the main diagonal. Well, the main diagonal is, there's only one diagonal. Well, I suppose there's two, okay, but the main diagonal is just the number 4. So what we have is that the trace of D is equal to 4. Okay guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this short video that I suppose walked through how to calculate the trace of a matrix was somewhat helpful. Okay, thank you.